Dear students, under the topic parallel asymptotes, here we have the second problem. The question is, show that the asymptotes of the curve x squared y squared equals c squared multiplied with x squared plus y squared are the sides of a square. First of all, we shall find the asymptotes for this curve and then graphically let us prove that they form the sides of a square. So in order to do that, first we shall rewrite the given question. So x squared y squared, bringing this term to the left side, it is negative c squared multiplied with x squared plus y squared is equal to 0. Even more simplifying this, we get x squared y squared minus c squared x squared minus c squared y squared is equals 0. Now we have to find the asymptotes for this equation. The first step is we have to check for the highest degree for this given curve. Now if you see here, the x, that is x squared y squared, together give us the degree 4. So the degree for this term is 4 because here we have x squared and here we have y squared. So adding the powers we get it as 4. And the degree of this term is x squared is 2. So this is 2 because c is a constant. We should not add it to find the degree of this term. So this is 2. And the degree of this term is 2 again because we have only y squared over here. And this is a constant term. So when we see the highest degree for this term is 4. So therefore there will be maximum of 4 asymptotes to this curve. So I have written here, therefore the maximum number of asymptotes for the given curve is equal to 4. Now we shall check whether we have asymptotes parallel to x-axis and y-axis. For that, first of all, we have to check the existence of parallel asymptotes, for which we have to see whether the highest power for x of the highest power of the curve for the term x exists in the curve. That is, what is the highest degree? The degree is 4. Now we have to check, do we have a term with x power 4? Now if you check here, we do not have a term with x power 4 because the highest degree for x here is 2 only. Now if you check here, the highest degree for x alone we have to check. So when we check for x alone, the highest degree for x is 2. Here also highest degree for x is 2. And we do not have an x term here. So therefore, we do not have coefficient for x power 4. So if there is no coefficient for x power 4, then it means that there exist parallel asymptotes to x-axis. So let me write that. So because we do not have coefficient for x power 4, parallel asymptotes exist for x-axis. In a similar way, we have to check whether we have coefficient for y power 4. So do we have coefficient for y power 4? No, because here the highest power of y is 2 only. And here also the highest power of y is 2 and here we do not have y term. So therefore we do not have coefficient for y power 4. It implies that parallel asymptotes exist for y-axis. So now we have found the existence of parallel asymptotes for x-axis and y-axis. Now next step is we have to find the asymptotes. So to find the asymptote parallel to x-axis, we have to equate the highest degree of x term in the given equation to 0. What is the highest degree of x term given? It is 2 only. For x alone, the highest degree is 2 because here we have x square and here also we have x square. So the highest degree for x term alone is 2. What is the coefficient of x square term? Here you have y square minus c square. So therefore equating the coefficient to 0, we get y squared minus c squared to be equal to 0. So therefore y squared minus c squared is equal to 0. So to find the asymptote parallel to x-axis, we are equating the coefficient of highest power of x term to 0. The coefficient of highest power of x term we found it to be y squared minus c squared and we have to equate it to 0. So from this, using the formula a plus b, a squared minus b squared, we can write this as y plus c multiplied with y minus c is equal to 0. Because we know that a squared minus b squared is equal to a plus b multiplied with a minus b. So using that formula, I have rewritten this, and from this we obtain y plus c equal to 0 and y minus c equal to 0. In fact, from that we get y to be equal to minus c and y to be equal to c, because from this we get y equal to negative c, and from this term we get y equal to c. So therefore the asymptotes parallel to x-axis is y equal to minus c and y equal to plus c. In a similar way, to find the asymptote parallel to y-axis, we have to equate the coefficient of highest power of y to 0. So let us do that now. So in the given equation, the highest power is for y is 2, because here we have y square. We should check for y alone. So when we check here, we have y square, and here also we have y square, and the highest power term is y square term. And what are the coefficients? Here you have x square, here you have minus c square, and so when we take it common, we get x squared minus c squared as the coefficient of y square. Now we have to equate the coefficient to 0. Therefore we will be getting x square minus c square to be equal to 0. Now again, in using the same method, from this we will be obtaining x to be equal to minus c and x to be equal to c as the asymptotes parallel to y-axis. So therefore we have found all the 4 asymptotes for the given curve. So 2 asymptotes are parallel to x-axis, 2 of the asymptotes are parallel to y-axis. Now after finding all the 4 asymptotes, we have to check whether the given asymptotes form a square. So let us draw these lines graphically in a square. First of all, we have to draw the line x equal to minus c and x equal to plus c. After that, we have to draw the line x equal to y equal to minus c and y equal to plus c, and whether let us check whether they form a square. So the line x equal to negative c is over here. So let me draw a straight line. And the line x equal to plus c will be here. And in a similar way, the line y equal to plus c is over here. And the line y equal to negative c is over here. We observe that they form a square. I have drawn it in freehand without measurement. So because all are same, you can see that here also the values are same, definitely they will form a square. So therefore the given the asymptotes for the given curve form a square. So hope you have understood this problem. Thank you.